after school as well. So Unit 4, Lesson 4B. Today what we're going to be focusing on is just a couple of things. We're going to be looking at a few more examples of balancing equations, and then we're going to learn how to construct skeleton equations. The reason why you need those polyatomic ions out is because they will show up. We're going to be going back over how to make chemical formulas properly. And in order to make chemical formulas properly, if you've got a polyatomic ion, you're going to have to know how to make a compound with a polyatomic ion. That's going to come back over and over again. And I told you I was helping you out a little bit. I'm printing the polyatomic ions for you. You will have them on the test on Friday. They'll be on the back of the test. That is something I haven't done in the past couple of years, so you're welcome. Actually, I will be giving you the polyatomic ions. You are allowed to use them, but you're still going to have to make the correct formulas with them, like know how to do that. And so I'll be going over that today. All right, Unit 4, Lesson 4B, skeleton equations and balanced equations. It's a pretty quick lesson, but I have a decent amount of examples on skeleton equations so you understand what to do. We're going to go ahead and start with a couple more balancing examples. So what I'm going to do for these is I'm going to pause, write the question down, see if you can solve it first. So this is like a level 2. And you probably, if you're paying attention, you may notice you're seeing a lot of these questions that have carbon, hydrogen, and oxygen. The reason why you're seeing these specific elements show up a lot, this is a very standard type of reaction called a combustion. So this is the reaction that happens with fire. If I was burning something like paper, this is similar to the reaction that it would undergo. There are other types of reactions. I'm not testing the types of reactions like combustion, combination. I'm not testing that on Unit 4, but that will be tested on Unit 5. So it's not going to be on Friday test because I haven't taught it yet. But this is a classic actually type of reaction, which is why you're seeing a lot of examples with carbon, hydrogen, and oxygen. So in the next unit, you're going to learn, oh, this is a reaction that happens with fire. This is a combustion reaction. So if you want to beat me to the answer, once again, I'm pausing to give you a little bit of time to do that. If you feel like you've got the idea of what to do here. If you've done the homework, you may feel semi-comfortable with this. The goal is to fit in the right numbers. So you have to change the numbers in front, the coefficients in front here, until you get the right amounts. I'm going to start preparing just showing how it can be done, but you don't have to write a chart. The chart is just to help you keep track. So the first thing you're going to want to do is count how many of each atom you have, right? How many carbons do you have on the left-hand side? 7. How many hydrogens? And oxygens? 2, right? Because all the numbers in front at the beginning are 1. Before we change anything, all the numbers in front are 1. So whatever the subscript is, that's how many you have to begin with. On the other side, how many carbons do we have? Hydrogen and oxygen, right? And what I usually do is I make a little note for myself that I had to do 2 plus 1 to equal 3, right? So I've got this situation going on. Everything's wrong right now. Nothing is balanced. How do we start fixing it? Right? So is there an element that I shouldn't start with? Don't start with oxygen. That's the only guideline, right? As long as you don't start with oxygen, you're all right. If you start with oxygen, like I said, it could be a very, very stressful process for you. And if you do that on the test, you may never finish the test because it will take forever to try to balance it. So don't start with any element that you have to add to get the amount. Do that one last. It will work out. All right. 1 goes to 7. What number do I put in front? Because we're multiplying these two, so it's 7 times times 1 is 7, because we have to multiply.
Pardon the interruption, faculty, staff, and students. At this time, we will be conducting a cardiac arrest drill in room 69. Again, we will be doing a cardiac arrest drill in room 69.
They're just letting everyone know that there's an ambulance that shows up that nothing's really bad going on. They're just doing a drill, just like a fire drill, so that the staff is prepared if anybody ever had a cardiac, like what to do. All right, so how many oxygens do we now have? We know we have 7 carbons, but now we have a different amount of oxygens because we put a number in front of carbon dioxide. We have 14 oxygens in carbon dioxide, but how many total do we have now on this side of the reaction? 15, right? 14 plus 1. Are we good with that so far?
Yeah.
Okay, so I have 15. So ignore oxygen. You could ignore it till you do everything else, but I just wrote it in just to say how many we have. Carbon, we're good. I'll just put a check mark there. Yay. Hydrogen. I want to make a 2 equal to a 14. So the number here is 2, so I have to figure out what number to multiply with 2. These two numbers always multiply is the main idea here. And that will give us the total amount of hydrogen. And so this number is 7. You're absolutely correct. So 7 times 2 is 14. But because we put a number in front of a compound, we have to change the amount of every element in that compound. So then, how many oxygens do we have now? 7 times 1 is 7. And then 14 plus 7 is what? 1. Because you're taking the total amount of oxygens in this compound and adding the total amount of oxygens in this compound to get the total amount for the entire side. So this right here is just a chart to help you keep track of what you have. Don't take it too seriously. This is just to help you keep track. What's going on here is what matters. These are the numbers you have to change. So 7 times 2 is 14 oxygens. 7 times 1 is 7 oxygens. And we need the total amount for the right-hand side of the equation. So that will be 14 plus 7. A lot of students get confused because they think you have to add 7 to 15, but that's not right because this 15 is already a combination of 2 different things. Yeah, that's why I said be careful with the chart. The chart's just to help you remember how many you have on each side. So you should be using this to get your total count, the numbers up here. So I've got 21 oxygens. Are we okay with that now? 21? Okay. So my hydrogens are good. If I change anything that has carbon or hydrogen, I will mess up my carbons and hydrogens again, so I don't want to do that. So I need to now change 2 oxygens to 21. Right. So we've got an even number, and that's why I said I want to show you a couple more examples of scenarios that could be confusing. I have an even number. I need to multiply that to get to an odd number. So what can we do? So there are 2 options, actually. And this is something that always blows everyone's minds. You can use decimals as long as your total amount of atoms is a whole number. You cannot end up with a fractional amount of atoms because that doesn't exist. But, like you suggested, if you multiply this by 10.5, that's the number. That would actually work out to 21. So 10.5 is a possible option. If you are decimal or fraction phobic and you don't like that, the other option is to multiply the numbers by each other, meaning multiply 2 by 21 and multiply 21 by 2. And then everything would be double this because of that. So there are actually 2 options to go with here. One is using a fraction or a decimal, and the other one is to find what we call the lowest common denominator in math, where we multiply the numbers by each other to get the first number they both go into. And so this is one possible answer. The other correct answer would be 2 C7H14 plus 21 O2 goes to 14 CO2s plus 14 H2Os. And if you put either of these on the test, like on a written question, they're both correct. Either of them are correct. that's up to you. Like that's an individual decision. Now, the reason why I even teach this in pre-ACE is because in the ACE class, in the college level class, Cambridge does use decimals or fractions in a scenario like this as their answer. So you need to be familiar with the fact that it's permissible to do this as long as the total amount of atoms equals to a whole number. It is permissible to do it. All right. Are we okay with this idea? Yes? That was the one scenario I wanted to approach. I had one more scenario on balancing I wanted to teach you or approach before we get into the topic for today. So last one, level 2. But this is level 2 approaching level 3, but it's definitely doable. Go ahead and write it down. See if you can solve it. For those of you that did do the bonus questions on the homework, this should be easy mode if you were able to understand those. If you weren't, then make sure you're carefully tracking along. You may recognize this equation because this is the overall reaction for cellular respiration. Or, sorry, for, yeah. So in biology, I think they present you with the already balanced equation. And for example, in honors bio or a previous bio class. But how do we balance it? So I'm giving you a little bit of time in advance of me if you want to beat me to the answer. Solve it in a couple of minutes. Yes. You want me to check?
Yeah.
You're good at that. Okay, so let's go ahead and start solving it so we can get to the other thing that we need to do today. First step is to count how many you have. And on the multiple choice predicate test, you could be asked, like in the bell work today, how many total atoms do you have? And so you do have to make sure you know how to get all your counts correct and how to add all those up. So here, how many carbons do I have? How many hydrogens do I have on the left-hand side? How many oxygens do I currently have on the left-hand side? So I have 6, and I would do like this and just help myself keep track. I have 6 plus 2 is 8 right now. Ooh, I had to add. I'll put a star there, right? Meaning, save oxygen for last. You could ignore it till the end if you want. On the other side, carbon is 1, hydrogen is 2, and you're seeing this again because it's a very common product to make. 2 plus 1 is how many oxygens here? Another star. Definitely save oxygen for last because you had to add to get the total amount on both sides. So where do we start? I would start anywhere but oxygen. So top down, just to have like a strategy. Okay. Yes. 1 to 6. What number do I need to put in front of carbon to CO2 to make that happen? Remember, it's a multiplication, so it's 6 times 1 will make 6. But now we know this amount of oxygen changes to 12. And like I said, you could ignore oxygen for now, or you could add it up in each step if you're using the chart. If I do add them up, I currently have 13 oxygens on this side. What do I need to change now? My carbons are good. What needs to change now? Anything but oxygen. Because 8 and 13, those numbers are right.
The hydrogen.
Hydrogen, 2 to 12. What number do I put in front here to make that happen? 6. Okay. So 6 times 2 is 12. But now I also have to change the oxygens again. 6 times 1 is 6 oxygens in water. I have to add that to the 12 I have in carbon dioxide. So 12 plus 6 is 18. Yes. Go ahead, grab that. 18. Okay. So I have 18 oxygens on this side. I have 8 oxygens on this side, but you have a new scenario that you hadn't, or at least I hadn't approached with you before. These 8 oxygens are split between 2 different compounds, right? It's 6 oxygens here and 2 more here. And we need this total amount to add up to how much? 18. So would it make sense to change the number in front of C6H12O6? Yes or no? Oh, change that. You're going to change your carbon, you're going to change your hydrogen, and that's where you get into circular reasoning. And it does happen. If you make a mistake here, you could end up on a question for a very long time and never get the answer. So we don't want to change this. We can only play. I was like, we can only fix this, the oxygen by itself, because it won't affect anything else. So what can I add 6 with to get to 18? What does 6 add with to get to 18? And are you allowed to use a calculator in this class? Yes. You don't have to do it in your head. It's going to be 12, right? So this needs to change from 2 to 12. So what number would make that happen? Correct. And so that's why you have to start, that's why this approach is level 3, because you have to like really start logically thinking through it to put how they're going to equal each other. So it's like a puzzle you have to solve. This is 6, because 6 times 2 is 12, and 12 plus 6 is a total of 18, and we're good. We're done here. This is a level 2. It starts to approach level 3. So because I've taught it to you, this is the hardest type of question that you would see for a balancing type question on the test, except for the extra credit. The extra credit is similar, though, in the way that you have to kind of work through a puzzle to solve how you're going to get the amounts correct. Extra credit, remember, is optional. You don't have to do it for the test. But if you want over 100, or you want to, you know you got something else wrong on the test and you want to replace it with the extra credit, you can do that. All right. We're okay with this, or at least the idea of what to do? Yeah. Yes? Okay. So that is balancing equations. It's a really major topic. It is fundamental to Unit 5. That's why I'm giving it to you now, so that when we start Unit 5, we're already comfortable with this technique, because it's one of the steps. It's not everything you have to do. So the next thing is, how do we write a skeleton equation? You're going to need to write this down. These are steps you're going to need to follow. What do I mean by skeleton equation? You are going to be asked, as the final thing to do in this unit, you are going to be asked from words to construct a proper chemical symbol equation. Meaning, I'm going to write down iron reacts with oxygen to make iron 3 oxide. I'm going to write that as a sentence. And you have to know in symbols that means this. This is a skeleton equation. So go ahead and write down the steps, and we're going to go ahead and do a bunch of examples on how to do this. So there's a bunch of steps here. I'm going to give you time to write this down. This is the final thing you need to be able to do for this unit. So construct a skeleton equation, meaning constructing the bare bones equation. I'm going to be telling you in words what you have, and you're going to have to figure out the chemical symbols for all of that. what are your reactants, what are your products. So the first step is you're going to have to write the chemical formula for the reactants and the formulas for the products. Then you're going to write an arrow in between your reactants and your products. You're going to use what we learned last class, which is how to interpret a simple equation to construct one. And then number 3, if states of matter are requested, you have to use the following designations. You have to use S for solid, L for liquid, G for gas, and AQ if what you have is dissolved in water. The key word that they'll use there is aqueous. So once again, this will be the final thing that you'll be asked a few questions about on the test. Like I said, I'll give you a breakdown a little bit later after I teach this. This is also going to be an excellent opportunity to remind you of some of the things you did need to memorize or work on from before the break. All right, I'm giving you time because everything here is important. The steps 1, 2, and 3, you need to have them written down. I'm giving you a few minutes to do that before we get started with examples. And we are going to see at least 3 or 4 examples on constructing skeleton equations, the types of questions you'll expect to see. All right, so this is where you're going to want those polyatomic ions because they will show up in some questions. You're also going to want to take out another handout that I gave you before break. I don't know that I have extra copies of it with me, but there is another handout that you'll see before break, the one about standard states. Because remember, you're supposed to memorize your elements like monatomic, diatomic, polyatomic, and if they're solid, liquid, or gas, that is part of what's in this unit. You may want to take out that handout if you, because that's going to come up into how you're going to solve these questions. All right, I'm giving another minute before I move forward. If you do need to take a picture, make sure to take a picture shortly because I'll be moving forward shortly to the practice examples. And once again, this is the last topic that will be on the test. I'm not going to put a lot of questions on this, but there'll be a few. There will be a lot of them. I can guarantee that. All right, so I'm about to move forward, and I just want to bring up, if you have this handout, you need to reference to it, look for it. It's from this unit. I can't remember if it's lesson, I think it's lesson 2 for this unit. We had went over in another separate lesson the monatomic, diatomic, and polyatomic elements. I gave you a trick on the periodic table in order to figure them out. You will need that trick for what we're going to do here. Because if an element is told to you that you have an element will be in its standard state, how it naturally exists, whether it's monatomic, diatomic, or polyatomic, and whether it's a solid, liquid, or gas. Just to quickly review, there was a quick little 7 you could write on your periodic table right here That gives you every diatomic element, which means it exists as two atoms together. And then there's hydrogen that also has two. The only two polyatomic elements are phosphorus and sulfur. They were P4 and S8. You are allowed a periodic table you can write on the test on Friday if you want to write like those pieces of information in when you get the test. Also remember that the states of matter of elements you are also supposed to memorize. This is part of the things from earlier before we went for winter break. The things that I told you you needed to know. All metals are solids except for one. Do you remember what the one is that's not solid? All metals are solids except for mercury. Mercury is the only liquid metal. There's actually only two elements that exist as liquids, mercury and bromine. And then the gases are a lot of the elements that are in the seven, nitrogen, oxygen, fluorine, and chlorine. All the noble gases and hydrogen are your gases. And so this is going to come into play in what we're about to do. So if you need this handout to reference back to for the practice questions, you can take it out. If not, we'll be going over it as we do examples. Go ahead and see if you can solve this one. At least write the question down and I'll go over how to solve it with you. It says write the skeleton equation for the reaction between nitrogen gas and hydrogen gas that produces ammonia. They tell you in parentheses that ammonia is NH3 because you are not being asked to memorize that compound name. And then it says, afterwards, balance the equation. So first you're going to write the skeleton equation, and then second, you're going to balance that equation. So write the question down, and then I'm going to teach you how to. You're going to want to underline the word skeleton equation. That's the key of what you're being asked to do. Want to get the reactant. And you want to get the product. In chemistry, if you see the word equation, chemical equation, skeletal equation, balanced equation, we're talking about this. Reactants go to products. So the equation actually is the chemical reaction itself. And the arrow you think of like an equal sign in a regular equation. That's why the two sides have to be equal to each other. Yes, welcome back. So let's see if we can follow this. Step 1. Write the chemical formulas for the reactants and the products. So can you read this to see what are your reactants? What are your reactants here? Nitrogen gas and hydrogen gas. So I'm going to write that out in words first, just because that gives us an idea. We know that the reaction is between these two, nitrogen gas and hydrogen gas, right? And what are we making? What do they tell us we're making? What is being produced? What is my product? Ammonia. So that's the words, but that's not what you're being asked for. What are you being asked for? What is the skeleton equation? You need the symbols. So basically you have to change words to their appropriate chemical symbols. So what is the appropriate chemical symbol for nitrogen? N. It is an element. So when you write it, you have to write it as it naturally exists. How does nitrogen naturally exist? Meaning, you have to address, is it monatomic, diatomic, or polyatomic nitrogen? Does it exist as a single one, or does it always exist as two? It's two. So if it's part of the 7, it is N2. Are we good with that so far? So if it's an element, you have to give the standard state. So we are changing words, right? Change words to symbols. That's what we're doing. Changing words to symbols. Yes. Go ahead and grab. So you can take the pass with you, just so you have it. Change words to symbols. Yes, we're good with the nitrogen. What's the state of matter? Did I need to write the state of matter? So that is a good point. Here, if states of matter are requested, I don't know if you wrote that down in the steps. If states of matter are requested, meaning I have to tell you I want them. And that's how Cambridge is as well. In some questions, they will tell you they want you to write the states of matter. In some questions, they don't. If they don't ask for the states of matter in the question, ask for it. Then you don't have to write that. So in this question, it does not say that you have to include the states of matter. So you do not have to. If you did, you would put a little g afterwards. But they didn't give you the state of matter for ammonia, so you wouldn't be able to predict that. That's why you don't have to put it here. What is the other reactant? Hydrogen, nitrogen gas and hydrogen gas. How do we separate them in an equation? What do we use? What symbol do we use to say? So the and, which I taught you last class, is plus, right? If you see this and that, it's nitrogen plus. Okay, hydrogen, what's that? What's the symbol for that? Is it 1, 2, 4, or 8? Those are the only options. Hydrogen is an example of a, as I said, you might want to go back here. It's diatomic. Hydrogen is definitely diatomic. Oh, so you do have to remember. And you have to memorize them again in Unit 5. You need to memorize the standard things for your elements, whether they exist as monatomic, diatomic, or polyatomic. This is something I'm reminding you because we did go over that before break. So I have nitrogen gas and hydrogen gas. Then you write the arrow, right? Ammonia. You have not been told that you have to memorize that name. So they've given you the formula. They said in parentheses, hey, it's NH3. So this is the skeleton equation. Right here, this is the skeleton equation. This is the answer for skeleton equation. So far, so good?
Yes.
So this, you may want to write underneath it, that is the skeleton equation. And then I added last night, because I put this in the homework, and I will put this on the test. After you make a skeleton equation, you could be asked to balance it. A skeleton equation tells me what I have, but it doesn't have the correct amounts necessarily. So how do we balance this? And I'm not going to write a chart because I don't have the space for it. But how would we balance this? Where do we start?
We start the two
Nitrogens? How many nitrogens here?
There's
One. One. So put a 2 in front of here.
And then we
And
get,
that fixes nitrogen.
and then we
2
get
times 3
hydrogen
is 6 hydrogens. How many hydrogens are here? So what number do I put in front of 6 hydrogen? What times 2 makes 6?
3.
And that's it. This is the balance equation. So write this down. The final thing you could be asked to do is you could be given a word equation, told the names of your reactants in your products, and you have to convert that into a skeleton equation, which is the correct symbols, and turn that possibly into a balanced equation. So we're going to do a few more examples, of course, before you get some to do yourself. For a lot of students, this is the hardest part of this unit because some things from Unit 3 are coming back, meaning names. Names are coming back. But like I said, I'm giving you a little bit of help by giving you the sheet with the polyatomic ions on the test. I will be providing you with that to help you out. First example, I'm holding here for 20 more seconds. If you need to take a picture, please do so now. I'm going to move on to example 2. Moving forward now. All right, here we go. Next one. Write it down, example 2. This time you're not even being asked to balance it, you're just being asked for the skeleton equation for the reaction that produces iron 2 oxide from iron and oxygen. Right, skeleton equation. This is very similar to in math, like in algebra, when you're asked if I do 3 multiplied by x plus 2 multiplied by y. If I say in words what's going on, you have to convert it into equation format. This is very similar to that. Welcome back. Okay. I'm giving you some time. This is the second example. Please write it down. We'll go over it again. Step by step. The goal here is to come up with the skeleton equation, which is the chemical symbols for your reactants and the chemical symbols for your products for the correct elements and the correct compounds on each side of the chemical reaction. So I'm just going to give an outline again. You want to make sure you first place your reactants and you first place your products correctly. So the first thing you have to do is read it correctly. Let's write the skeleton equation for the reaction that produces iron 2 oxide from iron and oxygen. So reading this, what are my reactants in words? Because from means it comes from, right? So these are actually the reactants. So in words, my reactants are iron and oxygen. What's my product? Only one.
2.
So the key word there, produces. Iron 2 oxide, right? So this is my product, iron 2 oxide. So this is in words. What are my reactants and what are my products? First, you have to read it correctly and place what you have on the correct side. But this is not the answer because we need to change this into symbol format. So how do we change iron into its correct symbol format?
Fe.
Fe. Now, when you do this, you have to, if it's an element, you have to give the correct state, standard state.
Subscript S.
They didn't ask for states of matter, right?
They did not.
So if they don't ask for states of matter, you only have to say whether it's monatomic, yes, or diatomic or polyatomic. Is iron monatomic or diatomic or polyatomic? And yes, this is something you have to memorize or have it written on your periodic table. All metals are monatomic. You have to write the one there? No, you just don't write any other number. If you don't write a number there, it's fine. But you have one iron. And it would be solid if you were asked for the state. You're not. You would have to give the state if asked. Oxygen. What is the correct symbol for oxygen as we breathe it in, how it naturally exists? So, and means plus, and then oxygen is O. Is it monatomic, diatomic, or polyatomic? It's part of the 7, like the 7 that you write, so it's definitely 2. Don't forget this. It's little details, but this is actually, you have to use the right symbol if you have an element. It's O2. And then that's my reactant. Now I have to get the correct formula for my
Fe2 O2.
Uh-oh. Iron 2 oxide. What is the correct chemical formula for that? Let's review. What do we do when we go from name to formula? We're going to first look for iron again on our periodic table, but we have to remember that the Roman numeral 2 means what? Plus 2, right? Look for oxygen on your periodic table. What's the charge of that? What's the charge of oxygen on your periodic table? Still have to know. I have mentioned everything in this class that you learned before. You still have to know. The charge of oxygen is -2, right? Goes -1, -2, -3, like that. -2. How do I combine these together into a neutral compound. If this is a +2 and a -2, then the charges just cancel out. So you don't have to crisscross. If you did crisscross, then you have to simplify, if you'll recall, to get this simplest number. But these cancel out. This is just FeO. FeO. Is it a big question? FeO. I tried. It's early in the morning. Are we done? That's it. Once you have the correct formulas for your reactants, you have the correct formulas for your products, you have completed your skeleton equation. This right here is the skeleton equation. Is it balanced? Were we asked to balance it? So you don't have to. There's no points awarded to it if it's not being asked for. So you stop here. This is the skeleton equation. All right, that was example 2. Now you're having to think, oh, I still have to know how to change names into formulas. And that's why I said this for a lot of students is probably the hardest part of this unit, because you're going to have to bring back things that you learned before. All right, let's try this next one. Example 3. Write the skeleton equation representing the heating of magnesium carbonate to produce solid magnesium oxide and carbon dioxide gas. I'm going to pause, give you some time. If you've seen me do 2 examples now. If you feel confident with the technique, try it yourself first, and then I'll go over the answer with you in a few minutes. I'm going to give you some time to write it down and try it yourself first. Same strategy. We want the skeleton equation, which means you need the correct chemical symbols, all your reactants, and all your products. Hint, there's a polyatomic ion somewhere in here, and I said you could use the chart for that. So the reason I'm pausing once again is to give you time to see if you can try working through it yourself for a couple minutes first. If you're not comfortable with the technique yet, you can wait for me. I'm doing a couple more examples, and then looking at the time, as I figured this is not a completely full class lesson, this is the only topic to cover today. I'm going to go over a review of the topics on the test just to remind you of what you need to go back and study, and then you will have time to work on the assignment today in class. You should have time in class. We're going to do 2 more examples. This is one of them. Then I'm going to go over an outline of what you can expect to see on the test on Friday, and then you'll have time to work on the skeleton equations classwork in class. So what's the first thing we should do? Well, we have to sort out what's on the reactant side and what's on the product side, right? So the first thing to figure out is we have to read it, basically. So I'm just writing this as an outline. You don't have to write this down every time. This is just me figuring out, okay, the first thing I want to do is I need to place my reactants and I need to place my products. So reading this, what is my reactant? Correct. That's what we're heating. So that's what we're starting with. It's like you're baking, you put all the stuff in beforehand, you're heating it, afterwards you get something. So magnesium carbonate is my only reactant actually here. Magnesium carbonate. And you can do this in your head. Once again, I'm just writing it down to illustrate the thinking process, the thought process. Products, what are they? It tells us. Again, that keyword is there. They could have said produce, they could have said yields as well. So magnesium oxide. And carbon dioxide. So that's in words what's going on, but we have to translate that to the proper chemical formula. So that's the work you have to do now. What is the proper chemical formula for magnesium carbonate? You should recognize from the ATE, so put this in your head. If you see that ATE ending, you have something specific you should be consulting your polyatomic ions list, right? Carbonate is CO3 2-, so you can go to the paper I gave you, because you're gonna get that on the test, and you can locate that that's carbonate. I also have them in the front of the classroom if you can see them. Carbonate. That means this is an ionic compound. So what is the charge of magnesium?
2.
Magnesium has what charge? +2. So that means you still have to remember, and this is like I said throughout the rest of this class, you have to remember that everything in group 1 is +1 in an ionic compound. Everything in group 2 is +2. That's the same concept we're using here. So magnesium +2. How do I put these two together properly?
Plus.
Magnesium has a +2 charge. Carbonate has a -2 charge. Do those two automatically cancel? Yes. So the correct formula here is NgCO3. Yes? So if you got that right. Now let's do the products. Magnesium oxide. What's that? Mg is +2. So you should always work out the charges. Oxygen is -2. Those cancel, so this is Mg. Oh. Yes.
The question says heating, so we put a triangle over the bar.
Over the arrow. Yes. Magnesium oxide and carbon dioxide. And means I write what?
Plus.
Plus. You have to separate your different products. You have magnesium oxide is one. Your other is carbon dioxide. Carbon dioxide. Do we know how to get that formula? CO2. So you're expected to remember that if I see di, that means I have 2 of it. CO2. Are we done?
Yes.
If you're asked just for the skeleton equation, this is confusing. Confusing? It can be. That's honesty. It can be. I'm fully confident. I'm fully aware that this is not necessarily an easy topic because it brings back ideas from the past and expects you to remember them. In order to solve, that's why I'm trying to go over it as slowly as I can. But the idea is you will have to sometimes change word equations into the actual, like, what are the symbols? And you see me doing it all the time in my head. What you're being asked to do is how to translate those words into chemical and then place your reactants in your product. This, by the way, is already a balanced equation. If you added everything up, you'll see it actually works out. This is the skeleton equation. This is actually also the balanced equation. All right, I have one more that I wanted to show you. This is the last one. Write the skeleton equation and then balance the following reaction. I'm going to go, like I said, over a review of topics on the test. Yes, as soon as the person that reads someone is out right now, when they come back. Yeah. So last one. Write the skeleton equation and then balance for the following reaction. So this is the, I think, the hardest type of question I could give you. I also put 1 or 2 of these in the classwork because you're going to see there's multiple polyatomic ions. So look for them and write out their formulas as you find them. There you go. So this is the, I think we are on example 4. This is the last example I'm going to show you. And you'll have 5 examples in your classroom today. You should have about 30 minutes to go over the classwork today. That way you can practice with each other and you can ask me questions if you get confused. So this one says, write the skeleton then balance for the following reaction. Ammonium phosphate reacts with barium hydroxide, ammonium hydroxide, barium phosphate. So this is, like I said, the most difficult type of question you can say, because it's got a lot going on. Reactants to products. The first step is you have to figure out what are your reactants, what are your products. Can you read through there and figure out what are the reactants? What are the reactants? These two, right? Both of them. So our reactants are ammonium phosphate and barium hydroxide, right? What are my products? To produce two things, right? Ammonium hydroxide now you may be understanding why I told you I was giving you the polyatomic ions on the test. And barium phosphate. Do you see any polyatomic ions in here? I am asking for you to recognize them. When you read the words, you have to recognize if you have polyatomic ions, so make sure to consult your list. Is ammonium a polyatomic ion? It is. I think I forgot to put it on one of the charts, but it is. What is the formula for ammonium? So I will provide that. If I give you a question with ammonium on the test, I will provide you with the formula. And it is one that you were asked to memorize in the unit. So ammonium is NH4+. What's phosphate? If you see ATE at the end, you definitely have a polyatomic ion. If you don't remember it off the top of your head, look at the chart. Remember, giving you that chart on Friday. Use your resources. What is the formula for phosphate? Okay, so but this is now what I'm going to expect you to do. Looking at ammonium being NH4 with a +1 charge and phosphate being PO4 with a -3 charge, you have to give me the correct formula. That's what I'm expecting for you to be able to do. Do you remember how to do that?
I do.
Honestly, you did. Great. Thank you. If you have polyatomic ions, you should write parentheses if you have to have more than one. If the charges don't cancel, you're supposed to crisscross to get the correct amounts. Kind of ringing a bell? Been like a month since we did that. So put parentheses around. You can put parentheses around both if you like. And then you put the number on the outside of the parentheses. And so your answer here would be NH4. What would go on the outside of the parentheses? You're tracking along. You're tracking along. Not -3, because you can't have a -3 amount of ammonium. It has to be 3. And then 1 phosphate. Do you put parentheses if there's only 1? You can. Do you have to?
No.
No. So you could just write it like this. NH4 3, PO4. Yes?
Yeah.
And what do we put for and? Plus barium hydroxide. Barium hydroxide. Barium, the charge is +2 from group 2 to periodic table. Hydroxide, look at your list of polyatomic ions. Look at the list, it should be there. Hydroxide, look at the list. You could have it memorized, but if you forgot it, look at the list. It's O OH minus. Now you have to make the correct formula. How do you make the correct formula between these two? Parentheses around the polyatomic ion. Put the 2 on the outside. So this is BaOH. So far, so good?
Yep.
Yes. Somebody's out. That's the reactant side. We have to do this as well for the product. So for the product side, we've got ammonium, which we already said was NH4+, and we've got hydroxide, which is OH minus 1. Do those charges cancel? Plus 1 and minus 1?
Yeah.
Yes. 1 minus 1 is 0. No crisscrossing needed. It's just NH4OH for ammonium hydroxide. And, what do we put for and? Plus. Barium phosphate. Barium is what charge? It's the same as it was on the other side. Plus 2. Phosphate, same polyatomic ion we saw before. You consult your list. Minus 3. Now what? Do 2 and 3 cancel? Plus
No.
2 and minus 3. Do they cancel to 0?
No.
So if they don't cancel, you have to swap them. So this comes here. The parentheses around your polyatomic ion, and the 2 goes on the outside. And this becomes Ba3O4 2. And this is your skeleton equation. Harder, right? So the questions are as difficult as the reaction is, what compounds you're working with. And you could be working with anything that we've studied in this class. So any element, any compound we've studied in this class is fair game for what you could be asked to make a skeleton equation for. So, this is not actually done, is it? What did it ask you to do afterwards? It asked you to balance it. And what level of balancing is this? 1, 2, or 3?
4.
2. Because if you have a polyatomic ion, all you gotta do is compare how many you have. You've got 3 ammoniums here. You've got 1 here, so you put up 3 in front. You've got 3 bariums here and 1 here, so you put up 3 in front. But now you've got 6 hydroxides. 3 times 2 is 6. We have to change this to a 6, which means this is a 2. And it's 2, 3, 6, 1. It's the balance in here. So this is hard. I know it's hard. This is the hardest type of question you could be asked on the test, and I'm not going to put a lot of these. But this is the level of what you could be asked up to. Yes. Go ahead. Take a picture. This is the last example that I'm showing you. We're going to go over an outline of topics on the test now. You'll want to take a quick picture of the last question. All right, next for the bathroom. All right, so what I'm going to do now, this is the last question for skeleton equations. You saw that we went over level 1 through, this is the most difficult I could give you. It's just how many polyatomic ions are there, and you have to swap the charges to get the corrected amount. I'm making it a little bit easier for you by providing you with the formula, but you still have to know how to crisscross. Still have to know how to either cancel the charges or cross the charges to make the correct amount. That's going to be a really big thing you're going to have to do in Unit 5, so that's why I want you to get some practice with it. All right, so let's talk about the test. The next slide, you do not have to write down in your notes, but if you want to, you can, or you can take a picture of it after I'm done taking notes. I always like to give you an outline of what to expect on the test. Test is next class. It's going to be, this is actually a short unit. We only had 4 or 5 lessons here. So there's not a ton of stuff on the test. And I told you that about half the test is balancing equations and then a couple of these skeleton equations questions. These are the exam topics you can expect to see on Friday. I'm going to write the exams with 30 multiple choice and 10 written questions. So just like all your other exams pretty much have been, it's 30 multiple choice and 10 written for a total of 40 points. So the 10 written questions, 8 of them will be balancing like simply like you did last class.
Oh,
8 out of 10 of the written questions are going to be balancing, and 2 of them are going to be skeleton equations, like what you saw today. So could be easy, could be difficult. Not telling. It could be anywhere. You have to follow the strategy. And like I said, you'll see them in today's practice questions, what you could be asked for. So that's what the written looks like. I'm writing it tonight. I'm just telling you what the outline is going to be. These are the topics that we covered. We started with intermolecular forces. Do you remember what those were? Uh-oh. You got to go back in, review. They were called dispersion, dipole, ring a bell?
yeah.
Hydrogen bonding. You could be asked questions about these in the multiple choice. I might also put on extra credit, you could get questions because there are some ACE questions with it. So you could be asked questions either in the multiple choice or in the extra credit with intermolecular forces. Those are the types that we went over. You have to be able to look at a compound and know how it attracts to other compounds, whether it's dispersion forces, dipole, or hydrogen bonding. The next thing we went over was states of matter. You have to memorize for all of your elements what states of matter they naturally exist in, and then you have to know about all your phase changes. Solid to liquid, liquid to gas, gas to solid, solid to gas. Study that. That was in a lesson that we had done this unit. Along with that, we went over this topic of heating and cooling curves, if you remember, where we went over what happens when you melt, you add energy, and you melt a solid into a liquid. So that will show up on the test. Make sure you had a homework. You can look back over in your Google Classroom to see what types of questions were asked there and in the handout that I gave you and the notes for homework. Remember, I'll also be posting quizzes, practice sets after school today. If there's any of the topics you were like, oh, I need to refresh myself on that one. Standard states for elements. You saw it today. This means knowing if your element is monatomic, diatomic, or polyatomic, and if it's a solid, a liquid, or a gas. When I ask for standard states, I mean this. So amounts, you have to know amounts, and you have to know states of matter for every element on the periodic table. I gave you a handout for that and told you that was the big thing you pretty much have to memorize. The periodic table kind of gives it away. Classification of matter. There is a chart I printed out for you. Matter separates into pure substances and mixtures. The pure substances are elements and compounds. The mixtures are homogeneous and heterogeneous. That's what that is. So being able to tell if something's homogeneous mixture, or something's heterogeneous mixture, if it's an element or a compound. That's classification of matter. Solubility. How do you know if something dissolves in water or not? Do you remember that? One of the lessons we did before break.
Yeah.
So this is what dissolves in water and how much. And we had went over solubility curves to discuss that. You may want to go back over that homework, look over your notes from that, and look over the quizzes that I had given you on that for practice. What dissolves? Yes. Tutoring is today after school. Then you have to practice for Friday. It's today after school because the test is on Friday. Balancing equations. We've been doing that the past 2 class periods, and I told you this would be a major component of the test. These two together, intro to chemical reactions, balancing equations, constructing skeleton equations, will be up to half the test actually, because we're going into our next unit. It's a major unit, unit 5, on chemical reactions. So a lot of the test is going to be on balancing equations and constructing skeleton equations, along with like just knowing chemical versus physical changes. Yes. What do you mean? It ends at 3:20, but it's just for like help on specific topics today, so you can stay as long as you like. Yeah. It's for like homework help and stuff. Yes. It's not like a standard like a. It doesn't have like I don't have like practice questions in it. It's just for like help. Okay. All right. Unit 4 exam topics. If you want to take a picture now, this is just to remind you of what we had reviewed over in this unit. If there's anything that you're like, oh, I forgot all about that, make sure you're reviewing it before Friday. remember on Friday, the first part of class, we will do some review. You will see some practice questions in the beginning of class on Friday to warm up for the test itself. There is tutoring. Somebody asked, there is tutoring after school today. If you do need help on any of the individual topics, you may come after school today. I have my room open because I know that Monday was the first day back. Monday's usually when tutoring is, but I am open for tutoring today after school. So I'm going to pass out the work now on skeleton equations. To be clear, for this homework, which is classwork that may be homework if you don't finish it in class, you are allowed to work together. So if you want to work by yourself, you can, but if you prefer to work with a friend, you can. There are 5 questions. For all 5, you're going to be asked for the skeleton equation. You're going to be asked to balance that equation. And I also want you to fill in the states of matter. So it'll show you the states of matter if you need it, but if it's an element, you've got to memorize it. For example, if it's oxygen, you've got to remember that oxygen is a gas.
Yes.
So here's the assignment. If you get confused with anything, please let me know. I'm here to help. And then also I'm here to help after school today. Yes, we can go next. One other person might have asked if they did. Remember, for this classwork, you can either work by yourself or with a friend. Make sure that you are diligently working through the rest of the class. Because if you have any questions or feel confused, and remember, this topic will be on the test. There won't be a lot of questions, but it will be on the test on Friday. I'll get the door. Give me a moment to pass. And here you go. You can work with a friend or you can work by yourself. As you go through, if you want me to also check your answers, please feel free to raise your hand and I'll check your answers and let you know if you're on the right track. Next for the bathroom. And then Mateo. I had said there was one person that might have asked you for your hand. Sorry. Perfect. Okay. So I'll see you after. So remember, if it's an element, you have to get the standard state. If it's a compound, you have to figure out from how to use the formula like we did last week. Yeah. You just don't know the states of matter. I just have to remember that. Just in your final. It's for one of them. As long as you have enough. Yeah. So you have to get the elements. The silver is over. Yes, you can.
¿Entendiste lo de la Dai, dos. Y poli son bastante más. Para la comic, entonces que tipo de pero yo sí en el examen yo me fallé y así que vienen varios. Es más cuatro. Y los restos tengo
Remember, if you want me to check something or if you're just unsure on something, raise your hand, let me know, I'm here to you could do 1.5 and 1.5. Like I said, there's sometimes where Cambridge will actually force you to do it. So that's why I said at least one should be aware of it, but that's possible.
Yeah, well, it's the word.
Right.
This works, right?
You made that hydrogen peroxide, so that does not work. You can never change the never change the numbers at the bottom. You change water to hydrogen peroxide.
So, what is the?
You have to only fix the numbers.
He did say that.
Or you change what you have. You change water to hydrogen peroxide. You're an alchemist. You do that. I heard him teaching, so like, you don't want to bother him if he's in the middle of teaching class.
So like we was preparing our lesson.
Oh, okay.
Because the last like 30 minutes of this class is when you're meant to do the assignment. So
He works on the next lesson.
Yeah, he works on
okay.
the next lesson.
That's efficient.
Yeah, so like he was getting ready for stats.
Cool. So the thing that I'm helping with is so that
Anda tantito, vosotros anda y soy tonto. Yo soy tonto, yo me he enterado 2 años. Qué ciegos. Ciego y sordo. Me voy a quedar sin piernas.
It's fine.
it's class.
O sea, antes estaba hablando así, bien. Ven un negocio y
Start working on it now.
entonces ahora yo me tengo que estar aquí. Me habéis obligado. Me habéis arrastrado aquí. A ver.
Here you're not writing out what are the identities of your reactions and what are the identities of your products. And then here is where you have to transpose this.
Yo lo hice así, la profe me dijo que estaba bien.
So once you get to here, you not so we know this happens. One variable nitrates, fluoride.
Pero me pregunta que de ella, no sé qué.
And that's the value. So basically that gives you the correct amount. Now you have the correct identity and the correct. So when we get to the math part of the class, we're going to be working with, well, if I had, for example,
Te dicen los
10
sólidos, los líquidos, los
how
gases y
many
los desconocidos.
BaCl2s would I make? And so you have to have the right that correctly for you to do any of that.
Ah, bueno. One ton. Me pidieron que pusiera el IQ.
The only thing you're in is two of them. But that's
Lo que ella dijo antes. Estaba pensando circularmente y me estaba haciendo bola. Tienes que abrir una computadora y esto tomar todas las notas de todos los slides.
Pero como ya empezamos a usar Copy, ahora no empiezan a
Ah, qué maravilla. Ya iba a decir, si te pones a hacer el examen, ahí sí candela.
si lo denunciamos, oye, pues, yo de la que cae la
All right, we've got about 15 minutes left in class. Feel free to ask questions if you're unsure of something. Also remember that I am available after school today. So they tell you the state unless it's an element
Creo que es así.
otherwise they'll tell So then
¿Cuál?
this is actually already valid. So you
Oh,
would just yeah, because there's one area on each side, carbon on each side. There's three outside here. But that's okay, sometimes they'll conclude.
¿Cuál es? Ah, exacto. Sí, sí. 2H.
And then, yeah. 3 times 2 is 6. 6 plus 4 is 10. This should be a 5.
Yo voy a dejar esa vaina así.
5 in front of oh, 2. Sometimes the special equation will be sometimes, but not all.
Ay, ¿en serio? Ay, yo no sabía eso, pero no, pero bacana. Pero estoy impresionada y ella tiene la segunda.
Did I give you the homework? Okay. I wasn't sure. Next to the bathroom, Mateo. I'm going to go ahead and start setting up for the next class real quick, and then I'll be back to help.